Hey guys and girls, welcome back to another beautiful video on this beautiful channel, this beautiful day. We're gonna keep working on this game now called the console RPG, and I did finish a few things last time. Let's just start the game. Let's see what's going on, if it even starts. Now I just want to get started with the attack system and stuff. And yeah, we did this enter to continue and the level up. Now I leveled up, I have stat points to allocate. I'll give it 0 to strength and then continue and then quit. That works, that's fine. Now what I want to do is I want to just go into that add stat point thing here, and then I want to do this. Whoops. I'm just going to copy this C out, added, wait, strength increased, and then we're going to do a new line. What's going on with my life right now? Why isn't this working? New line, is that it? I think I had some issues with my keyboard, but that's okay. I'm using my other keyboard now, so because I'm back home in my normal city where I study, so I have all my stuff here. Vitality increased, dexterity increased, and then intelligence increased. Okay, so that's it. Now I want to go into event. And let's see, this was the puzzle encounter. It's finished basically. Enemy encounter. And let's start this. We have a character. And we're gonna generate enemies in here. So what we're gonna do, we have our, where's our array? We have inventory. Item, game, functions, event. Why did I do this though? I made an inventory. Okay, yeah, because I started making this game before I actually before I actually knew what the hell I was doing. So we didn't complete remove item either. And okay, let me just think. Since this is kind of a tutorialish thing, we can make a new, because we're gonna have to use it for enemy and everything. We're gonna make a new item and a header file, call it d-array, and do this. Now this is gonna be a dynamic array. This is gonna be our dynamic array. It's gonna be something we use often and something we use for just about everything. We don't need to do enemy right now. Event is good. Puzzle, we can close puzzle. We can close weapon, armor, character. We can keep armor, weapon, character. No, wait, character we could keep, but whatever. I'll open it later. Game will be first. I don't know what the hell that is. Suck it. Main. So character. Put it right here. Then we'll close inventory for now. Character, event, and enemy, and the array. Okay, so that's all we need. Now call this, make a template type name T. So this is gonna be a generic array, and this is what we've been doing in the tutorial section, the C++ example section. So go watch those, but I'll explain as well as I can. You make a class called d-array, and then just a regular class, right? Nothing special. Give it a private and a public. And now you're asking, why are we making a class without a CPP file? Well, when you make a template class, a class that doesn't have a starting type to begin with for its members, then you can't make a CPP file because your compiler is going to make a object file out of it. And it can't do that until it knows exactly what types of things it needs. And when you use type name and templates, the compiler doesn't know until you actually create that object. So you're going to pretty much do that at runtime. We're going to be creating stuff and at compile time. So you're gonna have to just make an H file, and we have to define all the prototypes and get all the definitions in the same file. So let's start off with unsigned number of elements, unsigned cap. Let's do a T pointer array. That's it. And let's do a unsigned, wait, right here, unsigned initial cap. Okay, we got these 4 here. Now in private, we're gonna have a function called expand. We're gonna have a void initialize unsigned from. Okay, those 2 are gonna be private. We're gonna make public constructors. Okay, unsigned size equals 5. We'll start off by 5. Make a destructor, just simple. Now we're gonna make some functions. So of course we're gonna have our operators. This is important. We need to overload operators. That means that if we want to access something at, like, if we make an array called I, we want to access it at a certain index, we need to overload these bracket operators, or these, you know, these thing operators. Indexing operators is called. So for that, you need to do this: T reference operator this, and then within these const unsigned index. Okay, boom. We need to overload a copy constructor, the array const the array reference object. Okay, so we need to do that. We need to overload a void operator, boom, a assignment operator. We need to overload that. So const the array object. So now we overloaded our operators. Now we're gonna create some regular functions: void push, void remove, int or unsigned index, const unsigned index. So we'll remove it, and we'll have a bool in here, bool ordered. Now give it a default value of false. Now you'll know why I did this. It's pretty important. It'll depend on, if this is true, we're gonna have a longer type of delete that's gonna take more power, that's gonna keep the array ordered after the delete. Otherwise, if it's false, we'll do a really quick remove, like a really quick one that's good for enemies and other things. We'll just remove the last element, or we'll just remove the element at the index and point that pointer at that index to the last element, and then remove the last element's pointer. So that's just a really quick boom boom, and you're done with the remove. And the same thing with push. It's just going to push at the end. Now I could do an ordered push, but I don't really feel like that because we won't need that right now. Or we could for inventory, but you know what? We'll live without that. So push and remove, and then just regular ones. We need a unsigned size. Okay, we need to get the size unsigned. Now if we would like to, we could get the max size as well. Unsigned max cap. There we go. So we'll just start off with these, and then we'll see where we go from there. Now I'm gonna just put those in here below. This is how you do it. You remove this, of course, and then hold in Alt. Whoops, I think it's Shift Alt. Go down, just do that. We're gonna do all the operators and the constructors and the operators first, then we're gonna do all the functions. So the way you define these is really weird way. Don't think too much about it, just do it, because this is exactly how you have to do it. You have to write this template type name in front of every one of these functions. Okay, because you can have different, it doesn't have to be T. You can go watch that tutorial again on my channel, but on the other playlist. But this can be whatever, you can do whatever, but as long as it's that, this function can only use that name for its generic type. Okay, a generic type is just no type at the moment. It will become something later. So we'll be able to put in ints in here, we'll be able to put in whatever types we want. Okay, so this is how you want to do it. Then you want to do this, the array T, the same letter that you have in here, you want to shove in here, and then you want to just do this. Okay, that's how we're gonna do this. So just remember that. Go ahead and do this for all of these. Do it after the type, return type. Okay, just do it after the return type. I'm gonna copy this. So this is the tedious part, guys and girls, but I'm gonna try to do this quick, and then I guess do the attacking thing in the next video, I hope. But this is something we have to do because we're gonna be storing enemies in here, weapons, freaking items, freaking everything in the same type array. Okay, so just remember that and we'll be good. Now remove any other default thingies that you put in here because they're already in the prototypes. That's the only place you need them. So there we go. Now let's start off by creating this, and I'm gonna cheat if I don't get it right the first time. So this initial cap equals size, this cap equals size. So this is the main size of the whole thing. Remember when we made inventory? It's basically the same thing. This is just, it's for the generic type, any kind of items we can put in here. This number of elements equals 0. This array equals new C pointer this cap. So a big array of pointers to T, to a random, or not a random, but a uninitialized or undecided type at the moment, a generic type, pointers to that. And yeah, that's it. And then I'm gonna do this initialize. Now we haven't created the initialize function yet, and do it from 0, but the initialize function will create further down, so it'll work. Now the copy constructor is exactly the same thing. It's just that this initial cap will be this object dot initial cap, object dot cap, object dot number of elements, a new thing, a for loop in here to copy over everything. This number of elements, this are at position I equals new C with a copy of the object array at that position. Remember to dereference that array here, because if you don't, you'll get the pointer address, because this is an array of pointers. Now what that pointer at that position is pointing to is what we want to get. Now if you followed me in my tutorial examples, you'll know exactly what I mean, and if you followed the creation of the inventory class, you'll know what I mean, basically, because I'm pretty sure we did the same thing in there. I mean it was kind of the same thing. We used clone because the weapons are different. That's why inventory is special, because we used clone, because weapon and armor are descendants from item, or whatever you want to call it. They inherit from it. So that's why we use their clone function. And let me see, item. Yeah, because item has that clone functionality. So that's good. So that's why inventory has to be special. This is for all other generic things we want to store in here, for enemies and stuff like that. I don't want to use vector because it takes too much memory and it's just annoying. So there we go, this created. Now to delete it, we just do a for loop. This number of elements, delete this array at position I, delete all the pointers, what they're pointing to, and then we delete all the pointers themselves. Array. Now you want to do this because it's an array we're deleting of pointers. So yeah, here I'm deleting my hand, and here I'm deleting everything my fingers are pointing to. Okay, basically here I'm deleting all my fingers are pointing to, all the chocolates and the candy, and here I'm deleting my actual fingers. Okay, so then that way, first we have to delete this, otherwise if we delete this first, we'll lose all of these and it will be a memory leak. Now how do we do this? Well, if index is less than 0, first we need an error check, or index is greater or equal to this number of elements, we have a big error. So throw out of bounds indexing operator. There we go. But if everything is okay, we'll come down here. We will move past this throw, and then we'll just return this dereferenced. Dereference this array position index. Now I've created enough of these in my life to know exactly what I'm doing, but still we can get errors later. Now here, copy the copy constructor, basically, put it in here in the assignment. It's the same thing. It's just that what we're gonna do, wait, maybe this is gonna give me an error. What we're gonna do in the assignment operator though, first is we're gonna delete everything. We're gonna delete everything because remember, the assignment operator is called when two objects already exist. They have their own data, and one wants to become the other one. This copy constructor is called when you create an object from another object. So that one object doesn't exist yet. It's created using another object. And then it doesn't have anything from the start, so we don't have to delete anything. Here we have to delete everything that was there already. Everything. Set the cap and initial cap and everything. Make a new array. Copy everything over and initialize it. So basically that's it. Easy. And to expand, now here as well, we need a error check. This number of elements is greater or equal to this cap. Then we're going to do this. No, wait, this is going to be in push. Let me just copy paste this into push. Sorry about that. Push. And then we're just going to do this. Now this expand is easy. It's this cap. We double it. Double equals to 2. Then we're going to create a temp array. T pointer temp. Temp array equals new. T pointer this cap. So we have a new pointer array. Then we're going to copy everything over. This number of elements. This, no. Temp array at position I equals this array at position I. So we have a straight, all these pointers are going to point to everything our original pointer array is pointing to, basically. So we'll save those. Then we'll delete array. Delete array. We'll delete it. We'll remove all of those pointers, and we'll make a this array equals new T pointer. No, this array equals temp array because we already created those, and then this initialize from this number of elements. This initialize, okay. So let me just recap this. Increase the size, create a temporary array, move everything over to that array, delete the old array, make the old array point to the temporary array, and initialize it. And the temporary array will be removed down here. But everything that was pointed to by it will be pointed to by our original array here. So we save that data. Then to initialize, we just make a for loop. This number, this cap from basically this array at position I equals null pointer. So we initialize that. Max cap will return this cap. Size is return this number of elements. Push, if it's greater or equal to, we'll do this expand. Or else we'll do this array at position, this number of elements plus plus equals new T. Or wait, we need a const T element T element. There we go. We need to just shove that into push up here. Now to remove. Now this is one that sometimes I make errors on, so I might have to check this. I hope you understood all of this. As you add a new element in array, it's the same thing as in inventory. We increase number of elements at the same time. If number of elements is greater than cap, of course we have to expand because the array is full. All this stuff is just a regular, I guess. This just initializes everything. But yeah, let's do this. If ordered. So we'll do two types of deletes. Else, we'll do this. So if it's ordered, we'll have to do this. This array at position index. If index, and we have to do error check as well, is less than 0, or index is greater or equal to this number of elements, throw out of bounds, remove. But if we make it, we'll go down here, we'll say if it's ordered, we'll delete this array at index. We will go through everything. This number of elements minus 1, because we don't want to go all the way to the last one. We want to make everything from here point like diagonally up to everything else that exists, and then remove the last pointer. So it's going to be ordered basically from that point. So see how this is a worse type of remove, because we have to keep it ordered. We need a for loop in here. Imagine if this is a large array, we're going to have to go through all the elements every time. So I'll show you in the bottom case how we do it quickly. But so this array at position I equals this array at position I plus 1. So we'll point everything. Okay, and then what we have to do is we have double stuff. So we have this array at position this number of elements minus minus equals null pointer. So there we go. Now let me think, how long is this video? Can I show you? 20 minutes. Okay, we gotta end this. So this array, they're gonna point like that, and the last pointer is at number of elements minus 1. So we're gonna, number of elements is here, we're gonna go back, make a null pointer, and then make this the last. Yeah, so this is correct. And in here, if it's not ordered, that's kind of hard word to say. What we're gonna do is we're gonna delete this array at position index. So it's gone. This array at position index is now gonna point to this our array at this number of elements minus 1. So it's pointing to the last element, and then this array at this number of elements minus minus equals null pointer. So you see what happened there? Really quick, 3 steps. We removed the thing at that position. So imagine a array. Whoops, sorry guys. Imagine a array of like 5 things. Okay, all of these are full. We remove this. So this is 1, 2, 3, 4, 5, 6, 7. And we have another, our, you know, what do you call it, regular array with our pointers. So this is a pointer pointing to 1. So I'll just say 1, 2, 3. I just want to show you this quickly. 5, 6. I'm sure you understand this. And this is number of elements. Okay, it's always empty. That's why we always do number of elements minus 1. So number of elements would be 1, 2, 3, 4, 5, 6, 7, 8, right? Or 0, 1, 2, 3, 4, 5, 6. That's 7 elements. So that would be 7, I guess. But it goes up to 6. So that's why number of elements is always 1 more than how many you actually have. And then if I did this, I would remove 4, for example, this isn't pointing to 4 anymore. We remove 4. This pointer is now going to point to 7 up here. Boom. This pointer is pointing to 7. We want to remove that. So that's what's going to happen here. We're going to make that into null pointer, and at the same time reduce number of elements. So it's going to become like this. Okay, we're going to reduce it, and it's going to become like this. And this 4 is going to be gone. So that's how it's going to be. Exactly, that's how it's going to be. I hope you saw that. Maybe you can watch that again, and you'll understand what the hell happened. But that's exactly the steps that happen. Now this is pointing to that. This looks unordered, but in memory everything is just humble jumble. It's everywhere. It doesn't matter. It's not going to be ordered like this properly. Maybe this is going to be ordered nicely, but all of these, which are dynamically, these are our pointers. This is our actual array, and this is what our pointers are pointing to. These are going to be in the heap somewhere, just weird, lying everywhere. Okay, so remember that, how that works, and our delete and everything is fine. It should work. To try this out, I want to go into game, and in init game I'm going to make a d array of, first I'm going to include the array in game, include the array, and in game I'm going to make a d array of ints and call it ints, for maybe add 20 ints, ints dot push, add a bunch of 10s or random numbers up to 10, and then I'm gonna just print those out. Cout ints at position I, new line. And if this works, then it works. If it doesn't, I got a big error. Well, generating code, it's fine. There shouldn't be any real errors. Okay, so we got a bunch of stuff. Now this is 20 numbers from 0 up to 9 basically. So yeah, that works. We had no issues. We can just close it. Our dynamic array works. Now we can store shit in here and we're good. All right, this video is really long. Sorry about that, guys and girls. Yeah, I hope you learned something with this. Next video will make the attack and all that stuff. Okay, so take care, and I'll see you in the next one. All right, bye bye.